for small organizations, the thing we're seeing at the foundation now is a need for people to have situational awareness. Just like, 10 years ago, everyone, what's your network perimeter? Make sure you have a firewall, have your anti-spam tools, have a security policy around that perimeter. Well, today, a major attack vector is application vulnerabilities that come from bugs or mistakenly putting credentials in code and so forth. And small companies need to get their arms around this, because the consequences of a cyber intrusion or disclosing people's personal information and so forth are quite severe. And as a result of that, what you've seen is a huge growth in the entire software composition analysis and security tooling industry. Dozens of startups, companies like BluBracket coming in and helping organizations quickly understand what code are we dependent upon, both within our organization and stuff that comes from outside of our organization. Are there secrets in that code? Who is having access to the different repositories that we use to build the tools that we're deploying, whether it's on a cloud service provider or on premise. That there's an entire industry that's coming up, and I think you're going to see more and more of that as we see, in particular, high-profile attacks, such as the OpenSSL Heartbleed bug. The Equifax intrusion was a big one. I think what we all have to do is work together, and Google recently worked with us to create something called the Open Source Security Foundation. This are the security teams from Microsoft, GitHub, IBM, Intel, Red Hat, Google, and many others who are looking at, let's figure out what these emerging security threats are. Is it people coming in and do man-in-the-middle attacks on package management systems? Is it unintentional exposure of secrets and code from companies that are participating in large open source projects? Alpern pointed out, tooling is critical. We need to provide developers both upstream and small companies that are going through a digital transformation process with tools to do security scanning, software composition analysis, and understand where vulnerabilities lie. There's a whole set of best practices that we need to roll out there. We just did a research study with Harvard Business School's Lab for Innovation Science. We asked the developers who write the most widely deployed software in the world, the maintainers of those projects, about 2,000 developers, how do you spend your time? And writing new features was number one, and dead last was working on security. So we need to figure out how to change and create a culture of secure code responsibility. We need to have better ways to escalate vulnerability disclosure. We need to do digital identity attestation across the software supply chain. And then we need to figure out what these important shared projects are, like a Kubernetes, and do the kind of things that's going on in that community: third-party audit, constant dynamic and static code analysis, using modern security tools in those projects themselves. That's where we have to head towards.